In this video, we're going to use series to express a recurring decimal as a fraction. So we're going to try and express this number as a fraction. So I'm going to show you the easy way first, and then I'm going to show you the series way. The series way is a lot more complicated, but it gives you a better insight of what's going on. So let me show you the easy way which you should already know. So to express this as a fraction. To express this as a fraction, we would just say let this number be x. So now you can see that it's recurring here. So if you times by so let x be this thing. So now times both sides by 100. So 1, 2. So the decimal will be here. So express this well from here times both sides by 100. That will then give you this. So now if you get this, take away this. So on the left hand side 100x, take away x, that will give you 99x. And then if you look at this here, if you get this, take away this, well if you look at this, these will cancel out, these will cancel out, these and so on. The point is that if you get this, take away this, it will then give you a nice neat number. So now if you want to get x on its own, divide both sides by 99. So now you've expressed the number x as a fraction, where this is an integer and this is an integer. So now the series method. So if you look at this, it's repeating here and here and here. So you can think of this as being, you can think of this number as being the number 3, and then you plus 0.57. And then so that's this bit done, and then you add 0.0057. You can think of it like this, and then so that's this done. That's this done. Now let's look at this one here. So you can think of it as being 0.000057 and so on. So if you were to add these up, it would be 575. That's a 5 there. This there would be a 7. This here would be a 5. This here would be a 7. This here would be a 5. This here would be a 3, and so on. You can think of it as like that. So now now this thing here can be rewritten as this, because this bit here is 0.57, and then this bit here is really 0.0057, and this bit here is really 0.000057. So you can think of it like that. And now it's just you summing up everything from the first term all the way to infinity. Well, from here somehow rewrite this in this form. Once it's in this form, we can make use of this formula to obtain the sum of everything from the first term all the way to infinity. Forget about this 3 for the time being. So looking at this here, let's forget about the 3 for the time being. Let's just concentrate on this. So looking at the 3, but forget about the 3 for the time being. Let's just concentrate on the first, from the first term all the way to infinity. So well, if you from here you want to somehow rewrite this. Sorry, this should be plus ... From here you want to rewrite this in this form. But then, well, to rewrite in this form, it would be this. This is your A here, and then your common ratio is actually 1 over 100. 1 over 100. Now, if you would so from here you can rewrite this whole thing here as this, because when n is 1, put 1 into here. This will be 0. Anything to the power of 0, it will be 1. So your first term will be this. And then when n equals 2, put it into here. This will be 2 take away 1 will be 1. So 1 over 10, and then times this thing here. That will then give you this term. When n is 3, put it into here, and then the whole thing here will be this thing here. So the point here is that you can rewrite this whole thing here as this. Now that this is in the form of this, we can make use of this formula. So to sum up everything, hang on. To sum up everything, so this is your A, this is your R. So now follow the formula. Get A, so that's this A here. 1, 1. Take away your common ratio. Your common ratio is this thing here, because this is your R, and this R here is this. So this is your common ratio here. So now it's just a matter of tidying this up. If you tidy up the whole thing, it will then give you this. Okay.